Okay, gold. It's amazing how long we've been, as humans, fascinated by this shiny metal.
It really is.
Building empires, sparking all these adventures.
Absolutely.
And it still has this sort of mythical allure, wouldn't you say?
It's true. I think it goes beyond just the sort of beauty of it. The pursuit of gold has really driven some incredible feats of engineering, exploration, even scientific discovery.
Right.
Yeah.
And speaking of scientific discovery, you sent over some research about a place in Brazil, the Tapajós mineral province, the TMP, that has all the makings of, a real-life El Dorado.
Yep.
But like any good treasure story,
Sure,
there's some mystery to it.
yeah, that's a great way to put it. The TMP has this, just incredible potential for gold, but it's vast, it's complex. We don't fully understand. It's like having this treasure map.
Yeah.
But key landmarks are covered in mist.
Yeah.
We don't quite know the full picture.
And this paper, Predictive Mapping of Prospectivity for Gold in the Central Portion of the Tapajós Mineral Province, Brazil, sounds like it's trying to clear up some of that mist. But before we even get into what they found, can you walk me through how do geologists even start to find gold without just digging everywhere?
Yeah, so I think a really important thing to understand is that gold deposits don't just appear randomly throughout the Earth's crust. They form in what we call mineral systems. You can kind of think of these like a specific geologic recipe.
Okay.
You need the right ingredients, the right conditions, and a whole lot of time for those ingredients to sort of simmer and ultimately create a gold deposit.
So this study is like reverse engineering.
Exactly.
The TMP's gold recipe.
Yeah, it's a great way to put it. And they use some really, really cool high-tech tools to do it. It's like, we were talking about this a little bit before, but they're like these geological detectives using a mix of old-fashioned field work and then this really cutting-edge technology to try to uncover the secrets.
So what's in their toolkit?
So they use three main tools. The first one they use is called gamma-ray spectrometry.
Gamma rays. Like the Hulk.
It's
Is this where someone shouts, "It's science," and then the Earth glows green?
not quite that dramatic, but it is really cool. It's basically like we're giving the Earth this giant X-ray so we can use instruments to measure the natural radiation that's coming up from the ground, which can tell us about the types of rocks and minerals that are beneath the surface.
And how does that lead you to gold?
So gold itself doesn't actually emit gamma rays, but the types of processes that form gold deposits often leave behind a specific geological fingerprint.
Okay.
So in this case, they're looking for signs of something called hydrothermal alteration.
Hydro what now?
Hydrothermal alteration.
Okay.
Yeah, so imagine you have this superheated water, and it's rich in dissolved minerals, and that water is flowing through cracks in the Earth's crust. And as it does that, it interacts with the surrounding rock, and it actually changes the chemical makeup. And so those changes can actually indicate the presence of this mineral system that might be favorable for gold.
Ah, so it's like finding the clues left behind by these ancient hot springs.
Exactly. And so by analyzing the gamma ray data, they can look for specific things. In this case, they were looking for signs of what we call potassium enrichment and low thorium mobility, which are kind of, think of them as like a chemical signature that's often associated with these gold deposits.
Wow. It's incredible what they can figure out from like the air.
It's really amazing. Yeah, it's really cool.
So they've got their geological X-ray vision. That's not all they use though, right?
No, they didn't just stop there.
Yeah.
So they also use something called magnetometry.
Okay, now we're talking treasure hunting. Is that like using a metal detector, like a giant metal detector to find the gold?
You're on the right track. So magnetometry basically measures variations in the Earth's magnetic field. And the magnetic field can be influenced by different types of rocks and minerals underground. And it's especially good at detecting things like faults and shear zones, which we talked about a little bit earlier.
Right, those ancient scars in the Earth.
Exactly.
Where it's kind of cracked and shifted.
Exactly. And so those cracks and those shifts can act as pathways for fluids, including those hot mineral-rich fluids to travel through.
So you're looking for the areas where those gold-carrying fluids might have kind of congealed or been deposited along the way.
Precisely. And the TMP actually has a really dynamic tectonic history. It's been, pushed and pulled and cracked over millions of years, which means there's a lot of potential pathways for that gold to have traveled through.
Fascinating. So we've got the gamma ray spectrometry, we've got our giant metal detector. What's the third tool in the kit?
The third tool is something called a digital elevation model, or we call it a DEM for short.
Digital elevation model. Okay, that one sounds a little less exciting than gamma rays and giant metal detectors.
I know it does sound a little more, maybe a little drier than the other ones,
Yeah.
but it's incredibly powerful. So basically what we're talking about here is creating a very detailed 3D map of the Earth's surface. And so by analyzing these subtle variations in elevation and the shapes of the landscape, geologists can identify features that might indicate underlying geological structures, like those faults we were talking about.
Ah, so you're looking for the bumps and dips that tell you where the cracks might be hiding underneath.
Exactly.
Yeah.
And in a place like the TMP, where you have a lot of vegetation, a lot of trees, dense forests, it can be hard to see those features.
Right.
Just by looking. So this kind of analysis is really, really valuable.
So we've got our geological detectives. They've got their high-tech tools.
Well-
They're ready to unlock the secrets of the TMP. What'd they find? Did those clues actually lead them to gold?
Yeah. So you remember how we talked about hydrothermal alteration being like a key ingredient in that recipe?
Right, yeah.
They found really strong evidence of it in the TMP. And they found it exactly where they expected to in known hydrothermalized areas, which is really interesting.
Okay. So that's basically confirming, like, hey, this is where the action was millions of years ago.
Exactly.
Maybe there's still some gold, like, hanging around there.
Yeah, it's like a good sign. It's like, okay, we're in the right ballpark here. But it gets even more interesting. The study actually goes a step further and identifies two specific geological formations that seem to be particularly promising.
Oh, okay.
And those are called the Creparazone and Troposuites.
Okay. Two very important names to remember.
Yes, write those down.
Are these formations like giant containers of gold, or what makes them so special?
I wouldn't say they're giant containers, but think of them more like giant mixing bowls, you know, where over millions of years, all the right ingredients kind of came together. And so what they found was that these formations, especially where they come into contact with a certain type of igneous intrusions, these are called the Ingorana suite, seem to have just the right mix of ingredients and the right kind of geological history
Right.
to make them prime locations.
So, like, the geological stars aligned
Yeah.
just right in those spots. You've got the source rocks, you've got the fluids, the conditions are right.
Exactly. It's all about having the right ingredients in the right place at the right time. But it's not just the rocks themselves, it's also, you know, remembering those faults and shear zones that we talked about earlier.
Right, those ancient scars.
Exactly. Those are really important too.
Yeah, act like pathways.
Exactly.
Yeah.
Because the TMP has this really dynamic tectonic history. I mean, it's been pushed, pulled, cracked over millions of years. That creates a lot of pathways for those fluids to move through. And what they found is that specifically structures that run in a northwest-southeast direction
Okay.
seem to be particularly promising.
So, if I'm understanding this right, it's not just about finding, like, a certain type of rock. It's about finding the rocks that have been fractured and faulted in a very specific way.
Yes.
It's like finding the veins in a leaf
Oh, that's a great analogy.
where the nutrients flow.
I love that.
Yeah.
Yeah, you're looking for those pathways, and the researchers think that those northwest-southeast structures acted as like major conduits, you know, highways for those fluids to move through, which is why they're so interested in them.
This is amazing. It's like they're piecing together a treasure map, but instead of X marks the spot, it's geological formations and fault lines.
Yes. A treasure map is a great way to think about it because in the next part of the study, they actually create predictive models. So they're versions of a treasure map, if you will.
Okay, so we're talking treasure maps now, but how do you go from those geological clues to a map that says, dig here?
Well, that's where the really fun part of the study comes in. They took all that data, the geological formations, we've got the structural trends, signs of that hydrothermal alteration, and they used it to create not one, but 3 different models.
3 different models. That seems like overkill. Why do you need 3 treasure maps if they all point to the same X?
It's all about improving your odds, right?
Yeah.
Finding the treasure. So each model uses a slightly different approach, a different way of analyzing that data and looking for patterns. So they had what do you call a fuzzy logic model. And that one's a little more knowledge driven, you know, it relies on what geologists already know about how these deposits form. Then they had a weights of evidence model, which is more data driven. You're crunching numbers, you're looking for statistical correlations. And finally, they also used a support vector machines model,
Okay.
which is a type of machine learning. So it's basically learning from the data and making predictions based on those patterns.
Wow, so you've got old school geological wisdom, statistical analysis, and artificial intelligence all working on this problem.
It's really neat. It's really cutting edge stuff. But here's the really exciting part. What they did was they took the results from those 3 models and combined them to create what they call an agreement map.
An agreement map. What is that?
It's like if you took the 3 best treasure hunters in the world,
Right.
and each of them had their own map, and you said, all right, where do all 3 of these maps point to the same X?
Right.
In this case, what they did was they took the top 5% most promising areas from each of those models,
Okay.
overlaid them on a map, and the areas where all 3 models agreed, those are the hot spots. Right.
Okay.
Those are the areas with the highest probability of actually having significant gold deposits.
That's incredible. So they've got this high-tech, multi-model map of the TMP, highlighting the best places to go look.
What does that mean for someone like me who, let's be honest, is not going to be, heading down to Brazil anytime soon to dig for gold? Well, that's a great question. Imagine for a second that you're thinking about investing in a gold exploration company.
Okay, yeah.
Wouldn't you want to know which companies are focusing their efforts in those areas?
Yeah, that's like insider information.
Right, like you get a little glimpse into the future of exploration.
Totally.
So it's really valuable. It gives us this roadmap, this much clearer understanding of where we should be focusing our efforts, whether that's exploration, investment, even just our own curiosity.
It's like having a superpower. But even with all this incredible research, is there still like a sense of mystery surrounding this area? Like, are there still treasures out there waiting to be found?
Absolutely.
Right.
This study focused on, these specific geological formations and these structural features, but the TMP is huge.
Right.
Who knows what else is hidden beneath the surface, just waiting for the right explorer with the right tools and the right ideas to come along.
It's like, that's the beauty of science. There's always more to learn, more to discover. And a lot of times the answers just lead to even more questions.
I think that's a great place to leave it.
Yeah, thanks for this incredible deep dive. It's really given me a whole new appreciation for gold and the science behind finding it.
It's my pleasure. Glad we could dig into this together. And who knows, maybe this will inspire some future gold explorers out there.